In last lecture, we had started our discussion for first come, first serve CPU scheduling algorithm. We had picked one example, so let's try to start with the same example that there are three processes P1, P2, and P3. Burst time of those processes is 10, 5, and 5, and we had picked that arrival time is all processes are arrive at the same time. So we are going to start with the same one. We had designed Gantt chart for this thing, and what was the Gantt chart? Gantt chart says that since processes are arrived in the same order, so first of all, let's assume that P1 gets started at 10 unit of time it got completed, and P2 gets started 15 it got completed, then P3 gets started, and at 20 it got completed. So we had picked and generated different waiting time for each and every process, turnaround time for every process, then total waiting time, total turnaround time. Now let's take another example today and try to solve. And the example will be what happens if arrival time is different. So suppose arrival time is here 5, that is 0, and that is 10. Now how processes will get executed if this particular table is given to me. So what will be the chart? So first of all, what I need to do, I need to identify that which process arrived first. Why? Because we are focusing on first come, first serve. So which process arrived first? Arrival time says that P2 process arrived first. And at which time it arrived? That is 0. So P2 arrived and P2 will get executed it to its fullest, that is 5 unit of time. Now, once P2 get completed, at this point of time, is there any process which arrived? So my system says that yes, there is one process P1 which got arrived. So P1 will get executed for 10 unit of time, that is up to 15. Now at 15, system has again checked that is there any other process arrived, and it got that yes, one more process arrived, that is P3 process. And now P3 got chance for execution and it executed up to 20 unit of time. So what will be the waiting time and turnaround time for this particular scenario? So let's try to pick waiting time and turnaround time P1, P2, and P3. What will be the waiting time here? Waiting time means the process has waited how much amount of time. So let's start with P1. So P1, when it arrived at 5 unit of time. When it got first for the chance for the execution. So let's see here in this diagram, people arrived at 5 and got chance at 5, hence 5 minus 5 says that is 0. P1 has not waited even a single unit of time. Now what about P2? P2 arrived at 0 and it got immediate chance, so P2 has not again waited. What about P3? P3 arrived at 10 unit of time. And when it got chance for execution, that is 15, it means from 10 to 15 it has waited for 5 unit of time. So total waiting will become 5 unit of time. Now what about turnaround time? So we have already picked the simplest way to calculate turnaround time is waiting time plus burst time, or in Fcfs, and that is only for Fcfs, you can see here that what is the end time and what is the arrival time. So end time minus arrival time will also give you the turnaround time. But here we got 0, and our bus time is 10, so this becomes 10. Then here this one again waiting 0, then 5, here waiting 5 plus 5, that is 10, so it becomes 25. So this is my turnaround time and waiting time calculation for first come first serve algorithm. So we had picked in previous one, we had picked that if arrival time is not given, or if all the processes are arriving at the same, then how to proceed with the problem. If arrival time is different, then how to proceed. Now let's take one more scenario which covers few more details. Suppose P1, P2, P3, P4. Suppose I have four processes. Now I am taking bus time. Suppose all are having the same bus time. Please don't get confused. Different processes can have the same bus time. So do not get confused that nobody can have same bus time. Now arrival time I am going to consider. Suppose this comes at 0, this at 5, and this comes at 40. Suppose you got this kind of system. Now let's try to design FCFS for this thing, or chart of this particular problem. Now this is quite interesting, and it will cover all the doubts which you can have possible in first come first serve. So let's start with this one. From where I need to start the process which is having the smallest burst time. So I'm going to start with 0, hence P1 will get executed up to 10 unit of time. At 10 unit of time, we got two processes which arrived at 50 unit of time. Now since both processes arrived at the same time, then which process I need to consider, P2 or P3? Now once you find these kind of situations, always remember that process which is written in order above or first, that will be considered first if nothing additional information is given related to that thing. So to break any kind of tie, what we do, we pick the ordering which is given in my table if nothing is given. So from this one, what I'll do, I'll execute the P2 process because P2 is given here. So P2 get executed for 10 unit of time. Then definitely at 20 again, I need to cross check since there is only one process, that is P3. So P3 got chance for execution 30 unit of time. Now at 30 unit of time, there is no process is arrived, and up to 40, my CPU is idle. And this is very crucial thing. Why it is crucial, I'll discuss later. Let's pick first of all and try to complete this one. So at 40 I got P4 and it will get executed up to 50. Now, as I had discussed, let's pick why it is crucial. Turnaround time. For turnaround time, we had picked waiting time plus first time. And what is waiting time? Waiting time says that start time minus arrival time. So let's pick one by one what will be the waiting time here. What is waiting time of P1? 0, and it started with 0, so waiting time becomes 0. P2, P2 arrival time is 5, starting time is 10, so this becomes 5. P3 arrival time is 5, starting time is 20, so it becomes 15. Now P4, P4, now be careful, although at this point in my graph it is showing that here there is nothing. Do not consider this particular time with respect to consideration of P4's waiting time. It will again consider in the same manner arrival time. Arrival time is 40 and at 40 it immediate got chance. Before that, CPU was idle and we have nothing to do with the idle thing. Hence, waiting time is 0. Now, what will be the turnaround time? Waiting time plus burst time, so it becomes 10, then 15, 25, and another 10. Now, why I am focusing on this CPU idle thing? The reason is that you will not get this thing in your Galvin book. If you are studying with Galvin, in Galvin, most of your questions have same arrival time. They do not consider this particular thing. Hence, you will not be able to see such kind of idle things. And when suddenly this thing comes, students get confused and do lots of errors. So be careful. This kind of situation can also be possible. So that is first come first serve and various examples of first come first serve. Now what is advantage and disadvantage of first come first serve? So what is, first of all, let's take what is advantage. Advantage is most efficient one is that Fcfs is the most easiest one. It's quite easy algorithm. Easy in which sense? Easy in all sense, especially in terms of implementation. You can easily implement this algorithm without using any additional knowledge of different variety of data structures. It can be easily implemented. So that is the major advantage of it. Now what is disadvantage of it? Can you point out the disadvantage or drawback of it? The drawback is, let's take one example. Suppose I have three processes P1, P2, P3. Now all suppose arrived at the same time 0, 0, 0. That is arrival time. But the burst time for execution, that is 1505. Now Since all processes arrived at the same time, and if all processes arriving at the same time, what we do? We consider the ordering. So how these processes will get executed? First of all, P1, then P2, and then finally P3. That will be the order. Now, how much amount of time P3 have to wait? It's 2 bit. That is 1500 amount of time. So that is the major disadvantage of this particular algorithm, that it do not give priority to any specific process, or it do not give advantage to any specific process in any different kind of criteria. It only says that the process which comes first, that have to execute first. Now, let's take another example with respect to disadvantage of this algorithm. Suppose you want to take ticket of movie and you are in line, and the first person which is in line uh, is some kind of broker and wants to take 100 tickets first. Now the second one which is in line is again the same kind of person and wants to take 30 ticket, and you are the third person who only wants a single ticket to buy. Now definitely you will get irritated that I have to buy only one ticket. Please allow me. You all other are buying in bulk. So it will take extra time and my time will get wasted. So allow me for the execution of first. And that is the disadvantage of this particular algorithm, that it will not give you preference. And that is again, once disadvantage becomes another algorithm. So on the basis of disadvantage, we will pick our next algo. That is SJF, shortest job first. So in next class, next lecture, we will discuss SJF.